This example asks us to use data from the Sapling Learning Appendix to calculate delta G naught for the combustion of methane. So the appendix, this is actually a live link in the PowerPoint file. You can also just Google Sapling Learning Appendix and you'll find the information. And so what we need to do is look up the delta G of formation for each one of these four chemicals, and then use that to calculate delta G for the reaction. When you're looking at that set of data tables, the first column gives you the delta H of formation for the compound, the second gives you the delta G of formation, and the third one gives you the standard entropy. I have used textbooks where the last two columns are reversed. So the middle column is entropy and the last column is delta G. So make sure you always look at the headings on the tables so that you're pulling the data that you think you're pulling. So looking at that data table for delta G of formation for these different compounds, for methane, I found a value of negative 50.5. That's in kilojoules. Oxygen has a value of 0. Elements in their standard state are 0. CO2 has a value of negative 394.4. And water has a value of negative 228.6. Now, water has more than one value in this table because it's listed in more than one phase. So that is the value that goes with gas phase water, water vapor, steam, whatever you'd like to call it. So make sure that the number you pull from the table matches exactly the chemical that's in the equation. Okay, so now to calculate delta G naught of our reaction, we're going to take the products and we're going to take the coefficients times the heat of formation, or the delta G of formation for each one of those products. CO2 has a coefficient of 1. It has a delta G of formation of negative 394.4. And then we have water. It has a coefficient of 2 and a delta G of formation of negative 228.6. We're going to subtract from that the same sum for our reactants. CH4 has a coefficient of 1, and it's a negative 50.5. O2 has a coefficient of 2 and a delta G of formation of 0. Okay, so I'm going to calculate each one of these square brackets independently. So 1 times a negative 394 is just negative 394.4 with a negative sign, and then we've got 2, we're going to add to that 2 times a negative 228.6, and that adds up to give me a value for the first set of brackets of negative 851.6. Now inside of that second set of square brackets, I've got 1 times a negative 50.5 plus 0. So that's just going to be a negative 50.5. And now minus a minus, that's a tick-tock. That's going to turn into 2 pluses. So I'm going to have negative 851.6 plus 50.5. And that gives me a final answer of negative 801.1 kilojoules. So our objective is to calculate delta G. We did it using the tabulated data. We connected it to delta H of formation and the standard entropies, as well as to the delta G of formation data.